Let's look now at problem 18 in page 92 of the Segel's book. The pH of a 0.27 molar solution of a weak acid HA is 4.3. A. What's the H plus ion concentration in the solution? B. What's the degree of ionization of the acid? And C. What's the Ka? So let's write down this problem here. So this again in the Segel is at number 18 in page 92. So the pH is 4.3. pH is 4.3. And the concentration of the solution is 0.27 molar. And the first question, A, is what's the H plus concentration? B, what's the degree of ionization? And C, it's what's the Ka? Okay, so for this problem, let's assume that this was prepared by dissolving this acid in water and no pH adjustment. This is important down the road when we have other types of problem, that this is the kind of problem that the pH was not adjusted. pH was just that we put this thing in water, dissolved, and the pH happened to be 4.3. So again, let's have here the assumption that it was dissolved in the water and the pH landed at 4.3. So what I'm trying to say here is there was no pH adjustment, okay? So let's start then with the part A of the problem. The pH is given, 4.3, and now is asking what's the concentration of the H plus. We know that the concentration, the pH equals minus log of the concentration of H plus. Therefore, H plus concentration equals 10 to minus pH, 10 to the power of negative pH. Okay, so we plug in the numbers here. H plus is going to be 10 to the power of negative 4.3. We do some calculation here, or even the iPad is good, iPhone is good for that. So that 10 to the negative of minus 43. So that gives us 10 to the power of negative 5 molar. Okay, very simple, straightforward part, right? The second part, B, asks what's the degree of ionization. So we have here an acid that's HA, is a weak acid, so it was dissociating H plus and A minus. And that's why I told you the assumption that there was no adjustment of the pH, because if you adjust the pH, then we cannot assume that the concentration of H plus equals the concentration of A minus. Here we can, because there was no adjustment of pH, right? So if I know the concentration of H plus, I know the concentration of H minus, and I know the initial concentration of HA. So what we have here then, the dissociation is going to be concentration of A minus divided by the concentration of HA multiplied by 100, because we want to do that, to write that in percent, right? So A minus is 5, 10 to the power of negative 5 divided by the concentration of HA, which was given 0.27, and we want to multiply this by 100. So again, we are going to express that in percent, the final result, which is 1.85 10 to the power of negative 2 in percent. Okay? And finally, letter C, asking for the Ka. We know that the Ka equals the concentration of H plus times the concentration of A minus divided by the concentration of HA in the equilibrium, right? We know now that this reaches the equilibrium, the concentration of H plus and the A minus are the same, so we have here 5 10 to the power of negative 5. May I skip one step here and put this thing squared, because it's going to be this concentration times this concentration, right? Divided by the concentration of HA, which technically speaking would be 0.27 minus 5 10 to the power of negative 5, right? Because we have HA and the 5 10 to the power of negative 5 dissociated. So now what we have initially, one part of it is gone. But this is so small compared to 0.27, then we can neglect this thing here and calculate 5 times 10 to the power of negative 5 squared, and then we divide by 0.27 to give you 9.26 10 to the power of negative 9. There's no unit here, okay? I don't need to write a unit. So that's 9.26 10 to the power of negative 9. Again, this problem is straightforward, but it was no pH adjustment. If there's pH adjustment, we're going to learn how to deal with that later on, and there will be problem in that situation. We have an acid that's weak, but then after you get this dissolved in the water, we adjust the pH. Now, if you adjust the pH, we change the concentration of H plus, the concentration of A minus also is going to change, and there's lots of changes there. It's a completely different problem. This is very simple, and these are the 3 solutions.